Hello and welcome to my YouTube channel. In this video I will try to show you how to create an integrated library for your local project and how to start to create your first component. For the beginning we will go to our Altium version and we will create a new integrated library from File, New, Library, integrated library. For this integrated library are required two more components. One is right click on the integrated library, add new to project. We will add this schematic library. Go back to the project tab and one more time right click, add new to the project, the PCB library. This PCB library will contain the footprint of the component and the schematic library will contain the graphical symbol. Add also this one. Go back to the project. Save our integrated library. Local library, and inside of this PCB and also local schematic library. And the name for our library. And now we have these two components. The first one for schematic symbols. We have this view of this schematic library, and we will go on the Farnell. For this example I use Farnell website, and we will try to create our first component, this 0805 resistor with the 120 ohms is the value for this resistor. We have two methods. The first method is to take this part name, go in our Altium, on this panel, manufacturer part search, and here you can type the value for the symbol, and you can check where this resistor is available. With the red color we have distributors which for this part they don't have stocks available. As you can see here, the stock it's 0. And for Farnell we have these variants where we have here packaging, cut tape, or I think this is the only one. The Farnell for the moment has the only one available part for this register. And we have a possibility to open directly the data sheets from here, and if you are logging inside of Altium, workspace. You can also, for some components, have available here the second option, download, to directly download the symbol and the footprint. Now we will open the datasheet of this resistor. This resistor, it's a free thick film regular resistor with general purpose use, and we also can open the datasheet from here directly from the Farner website. And now we start to draw our first component. For this resistor, we need two pins. So we go to this tab, place pin, and I will place it here. Hit tab for change the designator. Our designator it's 1, it's okay. For the second will be 2, the name 2. Go back. And for the first one, we put here 1, 1. And for this, 2, 2. Some of these parameters can be hidden from these two visible eye. You can hide it. And now we start to draw our first resistor. For the moment, our grid is not the correct one, but we can change it from tools, document options, and we have here two possibilities to change the units from mils to millimeters, and we can change here also the grid and the snap grids. And now we can try again to place our first lines. You must to hit shift space to change the orientation. And as you can see, our line is the same like the pin, so we can select it and change the color to blue one. And now we can take this part, copy, paste, line, We can change a little bit the length for these pins. And now our first symbol for resistor is ready. This symbol can be customized. Some of us we can prefer this version, and some of us we can prefer of us prefer this version for the register. So in our case, for this demonstration, we can let it only one. And now we will save it, and we will go to the PCB library. For the PCB library, we can use the footprint wizard. And we have here options for resistors, capacitors. We'll set here the unit to the metric. Next. The type of the technology that it's used for this resistor is surface mount. Next, and now we should go in the datasheet to see if we have some information about the size of pads. As you can see, here are the dimensions, and here are the recommended pad dimension for different technologies, for wave or for reflow soldering. And we can take the values for the reflow soldering, and in this case we should check the Y and the X size, and uh, for 0805 we have 0.95 with 1.45. Next, the distance between the two pads is the G plus E. G plus E G plus 0.805 1 1.95 1.95. For the moment these are not important, we can skip, and we will put a name for our resistor. We can put directly the name from the manufacturer and finish. And now this is our first footprint. We can modify these overlays. For the moment our grid is set to 5 mils. To switch you can simply hit the Q key and now set the grid to hitting G to 0.1. Can delete this one and copy from here, Control C, select, put it back, and now we can select it and move it. Okay, let here 2. This is the top overlay. We can also add an extra layer. Depends on the requirements from different companies. This layer could be different. In general, they use some mechanical layer for adding the 3D model, and some of mechanicals from the seal screen, and some of mechanical for the ref destinators. And now for this component we can switch to the 3D view to see how it looks for the moment. Our 3D model is missing, so we can go directly to an website, 3D Content Central, and here we can search after creating an account. I finally remind my password and I enter in this website, and now we will look for our 3D model. We have found this model. I will uncheck this archive, the zip version, and now I will look for the step file and I will start to download it. I have the version of this resistor here, and now I will go back to the Altium. I go to the Place tab, 3D body, and now I will take this version and I will put it here. As you can see, first time when I switch to the 3D mode, our resistor is placed like this, not in the correct position. We have two ways. One is to take it, switch to the 3D model, select the body, and now try to hit space. As you can see, now the Z-axis and the Y-axis is moving. Double click and go to this rotation. And now we have our 3D model in the correct position. Another possibility is to let to be in the 3D mode. Go to the tools, 3D body placement and the line face width board. And now I will select this, and now the 3D body was moved in the same position with our footprint. And now simply can select it and hit space. Now we will switch back to the 2D mode, and I will take this 3D model and I will put it here. Now we can check our placement. How it looks. Sometimes depends on the requirements, and if the soldering for the small components like 0201 resistor or 0402 resistor, for this custom situation when this will be soldered by hand, we can also create special footprints and we can modify a little bit the length of these pads. And also for this, another mechanical layer will be placed. To go directly on this mechanical layer, you can hit Shift plus S, and now I will start to place. I will change the line width to 0.2. To came back to the normal view, press Shift S, and now our resistor is ready. The next step is to go back to the schematic library and to allocate for this resistor a footprint. First time we should save it, and now we can add our footprint to our symbol. Now press OK. And now for this symbol we have symbol and the footprint and 3D model. To check if our library it works or not, we can go back to a normal project, go to the components, and add our new library. And we have this component, and as you can see we have some parts that are missing. So which are these parts? We will go back to this resistor. I will select it, and here we have a tab where we can add the design IDs for this component. Will be something like this, the air, and for the designator depends on the here could be value, or in our case we can add this one, or here if you use database you can add the name, and now I will save it. And now if we go back to our library, we have this one, And this is our first created component in Altium Designer for beginners. Always this type of creation for the component could suffer some improvements, and sometimes Altium give you some errors and I don't know what happens exactly. I hope this video was helpful and useful for you. Thank you for watching this video and see you in the next video. Bye bye.